Let's begin with question number 2 on this paper. Okay, let's move it to whiteboard, please. So they say the area of a rectangle is 1 plus root 6. And then the length of one side is root 3 plus root 2. And then find without using a calculator. So without using a calculator, we're supposed to find something here. Sorry about that I was trying. So without using a calculator, the length of the other side in the form root a minus root b. Okay, let's begin this. So the length times width of any rectangle would actually equals to the area of a rectangle. Okay, the area of a rectangle is this part. So that means this number, so I just put an arrow first, it's going to be written here. So when they say the length of one side is this, the length is written as this part. Oh, then we also can see in the form, the other side is in the form, this means it's going to replace that. Okay, let's replace each correctly, please. So this is root 3 plus root 2, and this one is root a minus root b. And then this is equal to the area of the rectangle, which is 1 plus root 6. Okay, I'm just going to do the more natural approach of the conjugate method, meaning that let's rewrite this first like this. The brackets are just for emphasis, please take note. So root a minus root b, and then the orange one moves to the right, becomes the denominator, root 3 plus root 2. Okay, so this is the expression. So the reason why we cannot take this just straight away as an answer, because the left-hand side and the right-hand side are not exactly in the same form, though they may be equal numerically. Okay, let's understand the logic. We want the form is root a minus root b. Okay, so to achieve that form, it's quite a standard procedure in such a question when you read something like this, that you must think of the conjugate. Okay, please take note, 4 marks there. So that is a good indicator. There's a few other steps involved. So it's a conjugate for any third, conjugate of thirds. The argument works both ways. That means root x plus root y would have a conjugate of root x minus root y. Or in reverse, we can say the same statement, that is root x minus root y has its conjugate as root x plus root y, as per the arrow here. So I put the arrow both ways. So in this particular instance, we would want to see the conjugate for the denominator, always the denominator. Why? Because that's why they say we are rationalizing it, or rationalize the denominator. Rationalize means make it no more third, only rational numbers. Okay, so now we understand that meaning, why they sometimes call it as rationalize the denominator in some books. Okay, so just replace it as root 3 minus root 2 like that. So the conjugate is that, means now let's suitably multiply up and down, essentially just multiplying by 1, but to remove the denominator from having thirds, root 3 minus root 2 like that. Okay, now it's just a matter of simplification at this point. Okay, let's go ahead, let's do that. So we're going to rewrite nicely as we can, and just multiply straight away, also can. Okay, let's do the denominator separately first, because the difference of 2 squares, because if you notice this is like a plus b of the same number, and this part would be a minus b of the same number as well. That means a plus b and a times b, as I put here, let's say at the top here, and a minus b equals to the difference of 2 squares. Actually, I shouldn't use a, right, because the a is used for something else here. Silly me. Okay, let's replace it with m and n. So m plus n, this will be m minus n. So this is m plus n and m minus n, which is m square minus n square. So this part I'm just doing the denominator here. So let's go ahead, please. So this will be root 3 m square minus root 2 square. So in which case, now we just need to simplify the numerator and this thing accordingly. Okay, let's do the multiplications. So this times this, root of 6 times 3 is 18. This times this, minus root of 12. And then this times this, plus root 3. Just times the number inside. This one is the next one. This and this, minus root 2. Oh, there's all this. Yep. And then the denominator, we square it. 3 minus 2. Aha. So the whole denominator vanishes. You notice that? And regarding this root 18 minus root 12 plus root 3 minus root 2, at first it looks like something that cannot be simplified. We just use a bit of a third trick here. Please take note. I just do it in this box. You can write working like that. It's not an issue. Aha, as long as it's clear, which part is it? So 9 times 2 like that. So this is same as root 9 and root 2, in which case simplifies to 3 root 2. Okay, root 12 likewise is 4 times 3. Aha. So root 4, root 3, 2 root 3. So that means I just replace that 2. Please take note. This is 3 root 2 and this is minus 2 root 3. So the other two terms are similar. Just plus root 3 and minus root 2. If you want to rewrite, can, or if you can do it straight away, also can. Doesn't matter. So 3 root 2 minus root 2. And this one is minus 2 root 3 plus root 3. From which case, it's just simple algebra to see that the answer is 3 minus 2. 3 minus 1 is, this is 2 root 2 minus root 3. But this part, we cannot leave it like that because on the left-hand side is root A minus root B. So how do I do the reverse thing? So fortunately, it's not too difficult. The A part, that is talking about this. So the 2 root 2, what you do is, you just write it back as a perfect square. That means if it is a 2, it's the square root of 4, right? That means that, like square root 4, square root 2. Then put in the bracket, use the law of indices, root 8. So in other words, what I'm trying to say is, the answer is root 8 minus root 3. This is the final answer. Okay, sorry about that. Overlap in that. Okay, so I put it nicely like that. Yep, so A and B are integers. Thank you.